So to evaluate this, we use our special formula that the integral of 1 over a sine x plus b cos x dx is always equal to 1 over square root of a squared plus b squared ln of b tan half x minus a plus square root of a squared plus b squared over b tan half x minus a minus square root of a squared plus b squared plus k. So we're going to use this special formula to solve this. I'll prove it. So let's prove it before I was, or maybe let me solve the first one before I will now prove. Therefore, the integral of 1 over 3 sine x minus 4 cos x dx is now equal to square root of our a is 3 and our b is minus 4. So write minus 4 squared ln of b is minus 4, so minus 4 tan half x minus 3 plus square root of 3 squared plus minus 4 squared over minus 4 tan of half x minus 3 minus square root of 3 squared plus minus 4 squared plus k, and this is equal to 1 over 5 ln minus 4 tan half x minus 3 plus 5, this is 5, minus 3 plus 5 is plus 2 over minus 4 tan half x, this is minus 3 minus 5 is minus 8 plus k. But we need to do some touches. If I divide both sides by both the numerator, let's divide numerator and denominator by 2, I have 1 over 5 ln divided by 2, so I have minus 2 tan half x plus 1 over minus 2 tan half x minus 4 plus k. Again, if you notice in the denominator there is still common factor, which is I can factor minus 2, so it's 1 over 5 ln I can factor minus 1 here. I have 2 tan half x minus 1 over, I will factor minus 2 here, and I have tan half x plus 2 plus k. So what do you see? Minus 1 over minus 2 is half, and ln half is a constant because we have a product now. We have half times this, and ln of constant is a constant, so and that constant will add up to this. So our final answer is now 1 over 5 ln 2 tan half x minus 1 over tan half x plus 2, or in absolute value plus k, because ln half is a constant, so it will add up to this. Using laws of logarithm, that log of ab is equal to log a plus log b. So that's what I did here. So this is ln half plus ln this. So that's why it's a constant. So I added it to the constant, the integration constant. So that's the final answer. So let's prove it. But before we do it, there's what we call weierstrass substitution. It's named after a German mathematician, I think the 19th century mathematician, named Karl Weierstrass. Okay, that's it. From the name is a German name. Weierstrass is pronounced Weierstrass. So that's it. But looking at it, it seems it's weierstrass, but it's pronounced Weierstrass. So it's named after a 19th century mathematician, a German mathematician, Karl Weierstrass. I think it should be 1817. Oh, I don't know the exact. I think 18 something. I think it's 1815. 1815 to 1897. Enough of history. Let's focus on the math. So the mathematician noticed that when you substitute t as tan half x, it will convert any trig, that's any rational function that has trigonometry, to ordinary rational function. So we'll use the example, but let's analyze what he did. So you notice that if you substitute t as tan half x, it will convert that. So from here, if we have cos half x, this is tan half x, so meaning that if here is x over 2 as the angle, tan is this t and this is 1. Tan is opposite over adjacent, so the opposite is t, the adjacent is 1 because this is over 1. So the hypotenuse will be square root of 1 plus t squared. So we now use it to generate other trig functions. So we know that cos is 1 over sec. That's what he did. And sec, from our Pythagorean identity, is square root of 1 plus tan squared. And this is now 1 over square root of 1 plus t squared, because he said let t be tan half. So let's get for sine half. Tan is sine over cos, so meaning sine will now be cos times tan, since tan is sine over cos. So we are still correct. So this is now 1 over square root of 1 plus t squared times tan is t. So we have t over square root of 1 plus t squared. So to get sine from half angle identity, you have 2 sine half x cos half x. So because that's the main reason we want to get for sine and cos. So we need to get their half angle before we can get it. So this is now 2 times t over square root of 1 plus t squared times 1 over square root of 1 plus t squared. So we have that this is 2t over 1 plus t squared. Yes, 2 times t times 1 is that. This times this, the square root. The square cancels the square root. Y for cos. Cos squared half x minus sine squared half x. So which is the square of this, which is 1 over 1 plus t squared minus the square of that is t squared over 1 plus t squared, which is 1 minus t squared over 1 plus t squared. So again, there is one more thing. Since t is, okay, let me use another ink. Since t is tan half x, implies that x is 2 times tan inverse of t, and the x, if I differentiate ds over dt, is now 2. The derivative of arctan is always 1. That's 1 over 1 plus t squared. Yes. So dt. Yes. You need to know that whenever you're asked to solve any rational function that has trigonometry, we substitute sine as 2t, sine x as 2t over 1 plus t squared, cos x as 1 minus t squared over 1 plus t squared, dx as 2 over 1 plus t squared dt. So if we do this, we can convert it to a normal rational function. In weierstrass substitution, we are going to apply it here. Weierstrass says that we should substitute sine x as 2t over 1 plus t squared, cos x as 1 minus t squared over 1 plus t squared, and dx as 2 dt over 1 plus t squared. So let's use it here. So we have integral, as I'm proving. Our a sine x is now 2t over 1 plus t squared, plus b 1 minus t squared over 1 plus t squared, dx is now 2 dt over 1 plus t squared. So this is equal to integral. We now have, we'll bring out 2. We have 1 over, the LCM of this is 1 plus t squared. So it goes up, we cancel out this. So we now have we have 2 at, that's the numerators now, plus b minus bt squared dt. We need to make the coefficient of b squared 1, so I'll factor minus b. I have integral of t squared minus 2 at over b minus 1 dt. So we are still correct. If you open up this times this, will get back minus bt squared. Minus b times this will get back this. So we have 2 over minus b integral of 1 over. Remember, to make this a perfect square, okay, we know that for me to make this a perfect square, I will add the square of this over 4a, and our a, that's the coefficient of t squared, is 1. So we'll add a squared over b squared to make it a perfect square, and we need to subtract it so that we'll get back the original function. So this minus d will still get back to this original function dt. This is now, so we can still write it as 2 over minus b integral of 1 over, this is now a perfect square, 2 minus a over b all squared minus, this is a squared plus b squared over b squared dt. So we can still write it as 2 over minus b integral of 1 over t minus a over b all squared. We want to write this as a square, so which is now square root of a squared plus b squared over b all squared dt. So we still correct. We are going 2 over minus b. Do you remember the form? Don't know what I've done. Let's look at this. That integral of anything of this one, 1 over x squared minus a squared is all the x is always 1 over 2a ln x minus a x plus a. This is a special form of integral. So we'll continue. We now write this as, let me copy it to the other page. So the integral, therefore the integral of this is now of this form. Check, our x is now this, t minus a over b, and our a is this. So which is now, remember, we need to write our 2 over minus b. We need to put our bracket. This is now 1 over 2. Our a here is this, which is root a squared plus b squared over b. That's our a in that expression. Using this expression, that's a. Ln of t minus a over b minus square root of b a squared plus b squared over b over t minus a over b plus square root of a squared plus b squared over b plus k. So we still need to finish up something. This b goes up and the 2 cancel, so we are left with minus 1 over square root of a squared plus b squared ln of, we need to, as you can see, we see fraction, we multiply each by b. So we have bt minus a minus square root of a squared plus b squared over bt minus a plus square root of what? A squared plus b squared plus k. So finally, since we have minus here, we'll reciprocate using laws of logarithm. So this could be ln ln of bt minus a minus square root of a squared plus b squared over bt minus a plus that's square root of this raised to power minus 1 plus k. So this is equal to 1 over a square root of a squared plus b squared ln of b. This one moves off. I have bt minus, because of the minus 1 up there, laws of indices, so we reciprocate. This is down minus a plus this over bt minus a minus the square root of a squared plus b squared plus k. But we need to substitute back. Yes, our Weierstrass substitution, our t is tan half x, so we now have the final answer is this ln of, we substitute t as tan half x a squared plus b squared over b tan half x minus a minus that. So that's the formula. That's the formula we use in solving this question. Do you see the formula now that I use? So that's the formula we derive using Weierstrass substitution. Thank you.